I'm going to call somebody to read the problem. Hindi ko nakikita yung picture ni Juan dito, Erica. Erica, nandiyan ka?
Sir,
Okay, basa ko yung problem.
the 3 bars support the 100,000 pounds weight as shown. The 2 outer bars symmetrically placed are steel with areas of 6 inches square each. The center bar is copper with areas of 8 square inches. Find the axial force in each bar.
Okay, Erica, naintindihan mo ba yung problem? Naintindihan mo yung problem? Hindi.
Sir, kailangan pang basahin po.
Okay, so yan. Thank you. Anyway, explain ko ulit kung ano itong problem natin. So, meron tayong 3 bars. And these are vertical bars. And these are being placed symmetrically, positioned symmetrically with one another. On the 2 sides, this is made out of copper, and yung copper na yan ay meron siyang cross-section area na 6 inches square. And then sa gitna, steel pala yun, ano? Yung kabilaan, steel pala. Okay, 6 inches square ang area nila, no? Doon sa center naman, mas malaki yung area niya, 8 inches square. Pero siya ay copper. Ngayon, itong 3 bars na ito ay merong support doon sa itaas. Merong it is welded. All of these 3 are welded on the top portion. At dito naman sa bottom nila, dito sa baba, meron ding naka-weld dyan na load na weight. Na ang weight niya, ang resultant weight niyan is 1,000 pounds. Okay. Now, these 3 bars have the same length. Parehas ang kanilang length nung hindi pa sila na-deform. At parehas din ang kanilang length kapag sila ay na-deform. Okay. No? Okay. And given din ang elasticity modulus ng material. Sa copper, this is 17 times 10 raised to 6 pounds per square inch. Doon sa steel naman, is 30 times 10 raised to 6 PSI. So, ibig sabihin ng PSI, class, we're using the English system of units. Paminsan-minsan ay magkakaroon din tayo ng mga problems using the English system of units. Baka lamang makalimutan nyo rin ang English system of units. So, kailangan once in a while, I'm going to impart problems that contains English system of units. Hindi naman palaging metric. Kasi naman, kahit na metricated na ang Pilipinas, meron pa rin mga gumagamit ng English system of units. Meron pa rin gumagamit ng inches, feet, pounds. Yan, ano? Okay. So, please familiarize yourself also with the symbol. Yung pound is LB. At ito ay mahirap sa English units kung ano yung symbol niya parang hindi tugma dun sa spelling ng kanyang unit. Yung LB kasi galing sa Latin word niya na libra. No? Kaya LB, Latin word kasi yun, yung libra. Yung pound sa Latin is libra. Yung Latin is already a dead language. Ginagamit lang ito sa some of these terms in Latin ay ginagamit lang ito sa mga legal terms. No? Okay. And sa mga units. Symbol ng units. Remember class that these units are not abbreviated. No? Units are represented by symbols. No? Symbols. So hindi po abbreviation ang mga units. Ano? They are not abbreviated. Rather, they are being expressed in terms of symbols. Okay. So yan. Now, if we're going to draw the free body diagram of these three members, notice class that we have a resultant load that is vertically downward. And naturally, these three bars will experience some kind of stretching. Na-stretch sila. So, technically, ang tawag natin sa stretching na yun is naka-tension sila. No? So, that's the proper technical term. Instead of telling stretching or being stretched, ang ano natin dyan is naka-tension. So, all of them are under tension. So, ibig sabihin, class, lahat ito ay makakaranas ng tensile force. No? Each of them will have there is a tensile force that is exerted on each of these vertical bar, on each of these vertical bar. At yun ang isang yun ang isosolve natin kung ano yung mga force on each of this bar. We know that all of these are tension, but as to what magnitude that each of this bar will exert, ay hindi pa natin alam. Yun ang isosolve natin. So we may start by drawing the free body diagram and the geometry of deformation. So this is now the free body diagram. We can only see forces that are acting along the vertical, and there are no forces along the horizontal. So we are not going to anymore to consider equilibrium of forces along the horizontal, because anyway we can see that there are no forces along the horizontal. Okay, so we can also see that there can only be one equilibrium equation that we can use or employ here. We cannot even employ summation of moment above any point equals zero because it is not also applicable. We are only interested in the equilibrium of forces along the vertical. And as to the geometry of deformation, we can see that sabay-sabay na mag-deform yan in the same manner. Hindi pwedeng tatagilid yung ating horizontal bar, yung ating load. Hindi yan pwedeng tatagilid, hindi yan pwedeng mababaluktot, no? Okay. So, because of this reasoning, no, it is more correct to assume that the deformation of these three bars will be equal, all the same. Thus, you can see in here a broken line. Okay, yung dalawang broken line na yellow line na yung horizontal line, yan yung parang illustration ng kanyang axial deformation. So that we can say in your class that yung axial deformation niya, which is along Y, we say here that delta S is equal to delta C. So we can see, class, that this is also another example of a statically indeterminate problem. And we have three unknowns, and we need at least three equations to solve these three unknowns. In fact, ang unknown lang natin dyan ay dalawa eh. Because yung dalawang Fs dyan, pares ang value niyan. No? Okay. So, we start by solving the equilibrium of forces acting along Y. And we're going to consider upward forces as positive. Okay. And we can see, class, that we have 2Fs plus F sub C is equal to 1,000 pounds. So, kapag ako ang nagsosolve kasi hindi ko muna sinusulat yung unit as I go along with my solution. But I'm very mindful of my unit doon sa final answer ko or result. No? Okay. So this is the first equation to consider. And then doon sa deformation naman niya, where we stated that they have the same deformation, so we can represent this with an equation delta S is equal to delta C. The axial deformation of the steel is equal to the axial deformation of copper. Why? Because naipit sila eh. Naipit silang tatlo eh. No? So they are constrained to move in the same manner. Pipilitan na sila ay magde-deform in the same manner. Kahit na hindi parehas ang kanilang cross-sectional area, further, kahit hindi parehas ang kanilang modulus of elasticity, so magkakaiba sila ng mechanical properties, yung itong dalawang metal na ito. But because of the setup, no, they are constrained to move or to deform actually in the same manner. So ito po yung wisdom ng ito po yung concept ng ating analysis dito, class. So if you can recall the Hooke's law, the famous equation of this Hooke's law is delta is equal to FL all over AE.
Sir? Sir,
Yes.
excuse me po. Sir,
Yes.
pwede pa pakiulit yung explanation kung bakit hindi po applicable yung summation of f of x. Saka
Okay.
yung summation sa moment A.
Sige. Magandang tanong yan. Bakit hindi applicable? Dahil kung titinan naman natin yung free body diagram, meron ba kayong makikitang forces na nakaturo along the horizontal?
Wala po.
Wala. Okay. And then, kailangan nyo ba mag-moment? Hindi rin ano yung hindi akma itong mga equation na ito, no? So kaya they are regarded as not applicable in this particular problem. So you should know also when to choose your equilibrium equation, when to use them. No? When to use them. Okay. Now siguro applicable lang sa summation of moment kapag nag-check tayo, no? Nag-check tayo kung talagang yung moment niya is zero, no? Okay, but hindi na siya it does not anyway in any manner play a role in the analysis and solution of the problem. Okay. Did I satisfy your question?
Yes, sir. Thank you po.
Okay, so you're welcome. Okay. So, ganyan, kapag meron kang question kaagad, you can interrupt me and then mas maganda yung ganyan, no? Mag-butt in kaagad kayo and tell me tell me directly kung ano yung question nyo. Maganda yung ganun na interaction, ano? Okay. Now, if you can recall Hooke's law, Hooke's law is said to be a law that's only applicable to deformation of bodies, deformation of members, when the deformation is within the proportional limit only. We are speaking of an elastic deformation that is within the proportional limit. So any Excuse me, may tawag lang sandali. Hello?